Alright, hello class. Today we're going to be looking at lesson 11, which is on linear functions. And hopefully this one won't be too bad. Looking over the homework and stuff, this is all hopefully acts as review. So linear function is basically a function, that's got its x's and whatnot, but the highest x power allowed is 1. So really, the only possibility you have for a linear function is of the form y equals mx plus b. Okay, and if you remember, this m is the slope, and this b is the y-intercept. Okay, so the slope acts as the constant rate of change. Okay, so it tells you how the function changes over time, and if you remember, this is given as rise over run, okay, or the change in y over the change in x. We use deltas to mean change, or I like to think of it as vertical change over horizontal change. And let me just actually write it out. Vertical change over horizontal change. Okay, so how much is the line changing up and down versus left and right? And you notice I only put the arrow in this direction, and that's because in general how I like to think of this, I always consider the graph going from left to right, and then I let the y's dictate, the positive or the negative dictate whether or not we're increasing or decreasing. So we're always going to think of it in terms of left and right. At least I always think that's the best way to do it. Okay. The definition of the slope between 2 points. The slope between points x1, y1 and x2, y2 is given by this fraction. It's y2 minus y1 all over x2 minus x1. Our changes in y's over our changes in x's. So we just subtract our values. The only thing you need to make sure of, you keep these consistent. So if I take a y out of the second point, the x from the second point needs to be right below it when we set up this subtraction. All right. So in other words, let's say the slope between points, let's say 2, 5 and -3, 7, let's say, is this. We're going to take our y values. So if I say that this is y2, it's going to make this y1. So it'll be y2 minus y1. So 7 minus 5. Okay. And then now I have to stay consistent. So I already started with a 7 here. So now in the denominator, I need to grab this -3. It'll be -3, because here's my x2 minus my x1. So -3 minus 2. Okay. So we're going to end up with 2. And then on the bottom, the -3 minus 2 will give me a -5. Okay, so this is a slope of -2.5. That means as we go along, okay, as this is our horizontal change, this is our vertical change, okay, and the negative, okay, and we'll talk a little bit about that, but the negative means we're decreasing. Okay, so as we go to the right 5 units, okay, the line drops by 2 units. Okay, so that is how we calculate the slope. Let's take a minute to talk a little bit about what the positive and negative means. Okay, So if the slope is positive, okay, positive slope means the line increases as we go along. Right, as we go from left to right, the line is heading upwards. That's what a positive slope gives us. A negative slope, the line decreases. Okay. All right. And there are a couple other possibilities too. If we have a horizontal line, okay, that's when m is equal to 0, because we're not increasing or decreasing. We're constant. If you remember, this was constant. Okay, and this means or a horizontal line. So a constant, or so let me see, I can't read that, or horizontal line means that the slope is 0. And our final version is if we have a vertical line. This is when the slope m is undefined. Okay, and what we mean by that, this is when you get some sort of constant divided by 0. Right? You get division by 0 in your slope. That means you have a vertical line. Okay. The slope is also considered a measurement of how steep a line is. Right? So the slope measures how steep a line is. Okay? So the higher the number, okay, means the steeper the line. Right, so this red line here is steeper than this purple line. So we could say maybe that this red line has a slope of, say, 5, while this purple line maybe has a slope of maybe 3/2, okay, which is about 1.5. Okay, and then this green line, which is it's not very steep at all, but we see it's decreasing. I didn't draw it very well, but it's decreasing, but it's very, very not steep. So it might have a slope negative because it's decreasing, but maybe something like 1/5, -1/5, okay, when we compare it to this purple one. So the steepness doesn't really correspond with whether you're positive or negative. The steepness is the number itself. So I mean, you could have an extremely steep line that's going down, like this guy I just drew here, and its slope, if this is, say, 5, this seems a bit steeper. This might be -7, and it's negative because it's falling from left to right. Okay, so the positive or negative tells you whether or not you're increasing or decreasing. In other words, when you're going left to right, are you walking uphill or going downhill? And then the number itself tells you how steep it is. 0 being a horizontal line, and then, you know, higher numbers meaning steeper, all the way until a completely vertical line, which is some division over 0. And those of you who go on to calculus are going to learn that this is sort of a plus or minus infinity value when you divide by 0. Right? If you get pure division by 0, constant divided by 0, it's a blow-up point. It's sort of like a infinity. Okay, but that's sort of a spoiler alert for those of you who will be taking calculus later on. Okay, so Yeah, so that's what slope tells us, is how steep the line is, how fast is it increasing or decreasing as we go along. Okay, so now we're going to get into the process of actually finding equations of lines, okay, and then graphing them and start looking at examples. So we've talked about finding slopes, so once we do that, we need to be able to find the actual equation of the line. So there are two forms. The first we're going to talk about here is the point-slope form. Okay, so basically these are in the name here, point-slope. So basically if we know the slope, okay, and we know that the line crosses the point C comma D, okay, so here's the x value C, the y value D, then what we have is this equation y minus D, so y minus the y value is equal to m times x minus C on the right. Okay, so here are the values of the point. Here's the slope. So it's point slope. Okay, this form's pretty important because it's really the quickest one to get to. But once we get here, if we solve for y, so if we move the d over, distribute the m, do all that stuff, we get down to the y equals mx plus b form that we're more familiar with, the slope-intercept form. Okay, so here we have the slope m, and this is the y-intercept. Okay. All right, so let's look at an example where we employ this point-slope form, get it down to the y equals mx plus b form, and then we'll even graph it and see what we get out of it. All right? Okay, for our first example, let's find the equation of the line with slope m equals 2 and crossing the point -1, 3. Okay, so if we're going to use our point-slope form, another way you'll see it written sometime is y minus y naught is equal to m times x minus x naught. I think people get a little confused. They're not sure where they put their x's and their y's. So I like to use just different letters, C and D, so we don't get too confused. But basically we're going to take the x value from the point and put it here, the y value for the point and put it here. Okay, and then with the slope we have. All right, so it's going to be y minus the y value, 3, is equal to m, which is 2, times x minus now the c, the x value. Now here it's a -1, so we're going to do x minus a -1. Okay, so we get y minus 3 is equal to 2 times x plus 1. So this is the point-slope form. All right. If we want to find the slope-intercept form, okay, slope-intercept form, we solve for y. Okay, so to do that, we're going to start by simplifying here by distributing this 2, and then we're also going to add 3 on both sides. So we will start by distributing the 3, so we have y minus 3 is equal, I'm sorry, I think I said that wrong. We're going to start by distributing the 2, okay, and get 2x plus 2, okay, on this side, and then I'm going to add 3 to both sides. Okay, so we'll get y is equal to 2x plus 5. And there we go. Here we're in slope-intercept form. So what that means is we already knew the slope. We knew the slope was 2. We were actually given that. We knew the point that we were crossing through, but now we also know the point or the y-intercept 5. Now this corresponds to the y-intercept. So if I'm talking about the y-axis, I know that the line crosses here at the y-axis at 5. Okay, so that means it's actually the point 0, 5. Okay, All right, let's talk about how we actually graph this, and I'll show you the two ways we can do it. Okay, we can either use the point we were given and the slope, or the y-intercept and the slope. Okay, so let me show you. Okay, so here is the first way that we can graph this. We were given that the slope is 2, and the point that this line was crossing was -1 and 3. Okay, so we can go to -1, which is here, 3, 1, 2, 3, which is here. Okay, and so there's the point that this line's going through, and then we have the slope. Now remember, we have this as rise over run, but this isn't actually a fraction as it's given unless you reconsider this as 2 over 1. So as we go out 1, we go up 2. That's what the slope 2 over 1 tells us. So as we go out to the left 1, which I'll do here, 1, we go up 2. So here we're at 3, we go up 2 to 5. Oh, and look at that. This happened to actually give us the y-intercept. That won't always be the case. Okay. So we go up 2 over 1, up 2. Okay. The other way to graph is to instead start with the y-intercept. We found that the y-intercept was 5, so we can actually start at 5. Say, pretending we didn't have this already, we can start at 5 and then use the slope to find the next point. We go over 1 and up 2, 1, 2 to 7. Okay, so we go out to the point 1, 7. So from this point to the next, we go over 1, up 2. Okay, it's getting a little cluttered here, and my grid isn't perfect, but really all you need is 2 points to make a line. Okay, and so when you have the slope and any point, whether it's the y-intercept or just another point you were given, hey, you can graph your line from that. And let's look at another example. Alright, for this next example, it's a little different because before we were given the slope, now we're just told that this line goes through the points -1, 2, and 4, 7. So for this one, we're actually going to have to find the slope. Okay? So there's two things needed to find the equation of a line. For a line, you need the slope, and you need a point, whether that's the y-intercept or not. Okay? So let's start with the slope. Okay, so the slope m, right, will be my change in y. So if I say that this is y2, this is y1, I'll do y2 minus y1, so it'll be 7 minus 2. And then in my denominator, I'll take my x2, subtract by my x1. Right, so I have 4 minus a -1. Okay? So be careful with those negatives. And again, the order isn't so much important as long as you stay consistent. Right, you could do 2 minus 7 over -1 minus 4 if you want to do it that way, but you have to keep things matched and consistent. Okay? So what we're going to end up with is a 5 over, okay, here 4 minus a -1, that's 4 plus 1, which is 5. So we end up with slope 1. Oh, okay. That's not too bad. Then if I want this in point slope form, it's going to be y minus, and it really doesn't matter which one you choose. If you want to choose the second point, we'll take the y value out of that, so we get y minus 7 is equal to the slope, which is 1, times x minus 4. Okay, so here's the point slope form. The slope, the point, 7 or 4, 7, and then to get to slope-intercept form, we're going to solve for y. So we would distribute this 1, which isn't really going to do much. So we'll get y minus 7 is equal to x minus 4. And then we'll add 7 on both sides. Okay, so we'll get y is equal to x plus 11. Okay, so the y-intercept is 11. Okay, now if we were going to graph this line, there are a myriad of different ways to do it. Last time we looked at starting at one of our points and using the slope to find the next one. We can do that. We could start at the y-intercept and use the slope to find the next one, or we could also use the 2 points we're given. Okay, so for example, if I make an axis here, and we can actually start with the 2 points we were given. -2, 1, or sorry, -1, 2. And then the next point was 4, 7. So 1, 2, 3, 4, 2, 3, 4, 5, 6, 7. And I realize I did a mistake here. The 4 I added, sorry, the -4 plus 7 should be 3. My bad about that. Okay, my bad. Sorry. But notice when I graphed it, I immediately realized I'd done something wrong. So if you were to go from your first point to your next point using the slope, so if the slope is 1, that means as you go over 1, you go up 1. And we can use the next point, or use the slope to find the next point, which happens to be the y-intercept. Okay. Alright, let's look at another example. Hopefully this time we'll get a negative slope. Okay, for this one, we'll find the line between the points -2, 4 and 2, -1. I've cut out a lot of the explanation here, but we're going to find the equation of the line, we're going to graph it, do all that fun stuff. Alright, so we'll start by, once again, we need to find the slope. Okay, so the slope, remember, will be the change in y's. So I'll let this be y2 and this y1. So it'll be -2 minus this value here, which is a 4. And then for this next piece, I'm going to let this be my x2. So I'll have 2 minus now this x1, which is a -2. So just be careful with those signs when you do this. So what we're going to end up with here is a -5 over 2 plus 2. So we get a -5/4. Okay, so that isn't the friendliest slope in the world, but we can still work with it. What this means is as we go out 4, we're going down 5. Okay. Alright, now let's find the point slope form. In general, it does not matter which point you use, but I'm going to use this one, I think, the second one. So, point slope is going to be y minus this -1, okay, which is equal to our slope, -5/4, times x minus 2. Whichever point you use, just make sure you take both values out of it and put them with the right variable. So the y goes with the y, the x goes with the x. Okay, so what we end up with here is y plus 1 is equal to -5/4 times x minus 2. Okay, so there's our point slope form. now we want to get down to slope-intercept form. Okay, and maybe we'll get a nice intercept, maybe not. It's not guaranteed. So I'm going to distribute this negative 5/4. Okay, so I'll get y plus 1 is equal to negative 5/4 x. Then the negative and the negative, I'm going to have plus 5/4 times 2. Now thankfully, this 2 and 4, they play nice together, and I'll get some cancellations, and I'm basically going to have a y plus 1 is equal to negative 5/4 x, and this will be plus 5/2. So then for my next step, we'll subtract 1 on both sides. So I have y is equal to negative 5/4 x plus 5/2 minus 1. And the nice thing about 1, if I want to convert it into a fraction, it's always something over itself. So this will end up being 2/2. So at the end, let me do it over here, I'm going to end up with y is equal to negative 5/4 x plus 3/2. Okay, so 3/2 is my y-intercept. It's also known as 1.5. Now, let me show you how we can graph this line. Of course, like I said last time, since we have the 2 points, we could just graph a line between the 2 points and, you know, be done with it. Or what we can do is, and I'm going to show it that way this time, is when I make my, just to show you how we get there, when I make my axes, I'm going to take, say, this point here, which is 2, negative 1. So I'm going to go out 2, down negative 1. And then I'm going to use my slope to find the next point. So I'm going to go out 4. Alright, so 1, 2, 3, 4. And then I'm going to go down 5. 1, 2, 3, 4, 5. Okay. There we go. We went over 4, down 5. So over 4 from 2 is going to put us at 6, and down 5, should put down 5 from negative 1 will give us negative 6. Okay. So we're at the point negative 6, 6, and we can, you know, continue our line in both directions. Again, we only need 2 points. However you get those 2 points, it's really up to you, although be careful. MyLabs Plus may tell you specifically how they want you to do it. But you can either use a slope to find the next point, maybe you have 2 points. Another option is if you only had a single point and you found the y-intercept, you could do the point between the y-intercept and the point you were given. Okay. Yeah, so like that. Okay. Let's find the equation of the line between the point 3, 7 and negative 2, 7. Right, so we'll start by trying to find the slope. The slope is going to be, I'll let this be y2, let this be y1, so y2 minus y1, I'm going to get 7 minus 7 on the top. And on the bottom, I'll let this be x2 and this x1. So x2 minus x1, I'm going to get negative 2 minus 3. And so what I end up with is 0 over negative 5, which is going to come out to be 0. Okay? If you remember, a slope of 0 means we have a horizontal line. Okay? Well, let's put this in our point slope form anyway. Using this point, we could say we have y minus 7 is going to be equal to our slope 0 times x minus 3 in point slope. Well, 0 times anything is just going to be 0. You could distribute that or what have you, but you're going to get y minus 7 is equal to 0, or when you move the 7 over, y is equal to 7. So this is the equation of a horizontal line, y equals 7. So up here at 7, right, we get this horizontal line that I did not draw very well. And if you think about it, 3, 7 is like here. Negative 2, 7 is maybe here. So when you need to join those points together, you actually do get a horizontal line since the y's are the same. So when the y's are the same from one point to the next, you're going to have a horizontal line. You know, similarly, when the x's are the same, you're going to get a vertical line. So let's say when the x's are the same, okay, when the x's are the same, let's say we're going between the point 2, 5 and 2, negative 3. When you go to find the slope here, do your y2 minus your y1, so that would be negative 3 minus 5. And then you're going to do your x2 minus x1, so you're going to end up with 2 minus 2. So you end up with negative 8 over 0, which is undefined. Right? Can't divide by 0, so this gives us a vertical line. Oh, well, what do we do when I have an undefined slope? Can I give it an equation? Can I give it, like, put it in Pointslope formula? And sorta. What ends up happening is the equation, okay, of a vertical line. If you remember, the horizontal line was just y equals 7. The vertical line is going to be x equals 2. Right? Because if we were to graph this, when x is equal to 2, we have a vertical line. We see that the point 2, 5 would be like here, and 2, negative 3, which would be, say, here, both fall on this line. Okay, so all the points on this line are 2, some y. Right, so that's why we just say the line is x equals 2. All right. The last thing to really talk about as far as lines is concerned, remember, when you want to find the equation of lines or graph them, you need the slope and you need a point. Okay? Well, two lines are parallel if they have the same slope. Okay? So if two lines have equal slope, that means they're parallel. So the line 2x plus 3 and the line 2x minus 12 are parallel. And we can actually graph that and see it. Maybe not super well since we're talking about 12, but if I change this to 5, we'll have a better view of what's going on. So this one, we're in slope-intercept form. So if I know our line starts here at 3, right, and has slope 2, which means 2 over 1. So as we go over 1, we go up 2. So we go over 1, up 2. Right, so that's what this line looks like. Then if we go down to -5 and start a new line and give it the same slope, so that's what the second line is. Its y-intercept is -5, its slope is 2, so we go out 1, we go up 2. Okay? And again, I didn't draw these perfectly, but you can kind of see that if we did this on a for real grid, we have two parallel lines. Okay? So these lines are parallel. Okay. Similarly, two lines are perpendicular. Okay? If their slopes are negative flips, or negative reciprocals is what the actual word is, I think of it as negative flips. So if I have the line y equals 2/3 x plus 5, okay, and the line y equals -3/2 x, so plus 5, right? These are going to be perpendicular. This is the negative flip. We flip the fraction, negate it, and that new slope will be perpendicular. So let's graph these to actually see whether or not they satisfy that. So we're going to have to go out to up to 5. All right, they share the same y-intercept. They won't always. All right, but both of these have the same y-intercept, 5. So 2/3 x. Well, 2/3 x means we go out 2. Sorry, we go out 3 and up 2 from one point to the next. So we go out 3, then we go up 2. So something like this. For our second slope, we have -3/2. So when we go out 2, we're going to go down 3. So from left to right, we go out 2, then down 3. So out 2, 1, 2, down 1, 2, 3. Okay, to this point. And we can see that the lines we just drew, even though I'm not on a great perfect grid, you can actually see that these are, in fact, perpendicular. Okay, let's say I want to find the equation of the line crossing through the point 2, 4 and parallel, I should be careful with that so you don't think it's 11, parallel to this line, y equals 3/4 x minus 11. Okay? Well, the first thing we need to do to find the equation of this new line is get our slope. And we get our slope from the fact that the line we're looking for is parallel to this one. So we're going to grab our slope from here. Our slope, our new slope, same as our old slope, is 3/4. Okay? And then, well, all right, we got what we need. We got our slope, and now we have the point. So the point slope form is going to give us this, y minus the y value of our point, which is 4, and equal to the slope 3/4 times x minus the x value of the point. Okay, so there's the point slope form. And if we want to get to the y equals mx plus b version, we'll distribute and solve for y. Okay, so we'll get 3/4 x minus 2 times 3/4. Thankfully, the 2 and the 4 cancel a little bit, and we get 3/2. So we're going to get 3/4 x minus 3/2 on this side, and then y minus 4 on this side. And so we'll add 4 to both sides. Okay, now 4, if I want to add 4 to 3/2, I'm going to get a common denominator. So over 2, multiply the top and the bottom by 2, I'll get 8/2. Okay, so what we end up with here is y is equal to 3/4 x, okay, plus the -3 plus 8/2 will be 5/2. Or 2.5 if we actually wanted to graph that. Now, be careful with this because MyLabs Plus will actually tell you, make sure everything is a fraction and an exact answer. Okay, let's do another example. This one we're talking about the same sort of original line, but we want to find an equation now of a line that's perpendicular to y equals 3/4 x minus 11 and crossing through the point 9, -2. Remember, always, the first thing we need to do is grab our slope. Okay, so our slope is 3/4. Now, we want to be perpendicular, so we're not going to use the same slope. We're going to flip it and negate it. So our new slope is going to be -4/3. Okay, since we're perpendicular. Right, now, to get to the point slope form, it's going to be y minus our y value, which is a -2, so it would be y minus a -2, is equal to our slope, -4/3, times x minus our x value. Okay. So let's simplify this a bit. This is actually y plus 2 is equal to -4/3 x minus 9. And to get down to slope-intercept form, again we solve for y, so we'll distribute that -4/3. So the left-hand side won't change. We'll have y plus 2 is equal to now -4/3 x. The negative and negative give us a positive. 4/3 times 9. So the 3's cancel here and leave us with a 3 up top, thankfully. Glad we got rid of our fractions there. So we have y plus 2 is equal to -4/3 x plus 4 times 3, which is 12. And to finish this off, we'll subtract 2 on both sides and get y is equal to -4/3 x plus 10. And there we are in slope-intercept form. Okay, so our y-intercept here is 10. We also have this point that we were given originally, 9, -2. Alright, that should just about do it for this section, but I want to graph these and see if we get anything worthwhile. So let's graph our original. We have to go all the way down to -11 here to get 3/4, to get that y-intercept of 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's -11 for my y-intercept. And the slope is 4/3. Or, sorry, I said that wrong, 3/4. So when we go out 3, so our first slope we're going to be looking at is 3/4. So when we go out 4, 1, 2, 3, 4, we go up 3, 1, 2, 3. So we get a line that looks like this. Okay, you can see that. For my next line, I have y is equal to -4/3 x plus 10. So for this one, we go all the way up to 10. 1, 2, 3, 4, 5. And for the second slope, it's -4/3. So we're going to go out 3, down 4. So out 3, about right here, and down 4. 1, 2, 3, 4. And so I did not graph this perfectly. As we can see, it didn't come out perfect. But if you're on a not slanted and a a nice grid, it will come out to be, you know, perpendicular. Right? So that's pretty much that on this section. Remember, to find the equation of a line, you need a slope and you need a point. And you find that slope however you can, whether it's given to you, whether you're given 2 points, whether you're given some other line that you're matching it with. However you get there, just get there. Right? And that'll do it for that section. And I'll see you all in the next one. Cheers.